Hello everyone, Miss Katongo here. This is another physics related problem. But before we begin with the problem that has been displayed on the screen, don't forget to like and subscribe to my YouTube channel. Let's begin. Two trains on separate tracks move towards each other. Train 1 has a speed of that. Train 2 a speed of that. Train 2 blows its horn, emitting a frequency of 5 times 10 to the power 2 hertz. What is the frequency heard by the engineer on train 1? What is the frequency heard by the engineer on train 1? So, let's get our data. We have our first train and our second train. In our first train, we are told that the velocity of the train, or rather the speed of the train, is 1.3 times 10 to the power of 2 kilometers per hour, and the speed of our second train is 90 kilometers per hour. And finally, we are told the frequency of the second train being 5 times 10 to the power of 2 hertz. Okay, let's visualize this. We have our first train. Our first train in this case will be the observer, and our second train will be the source. Why? Because in the question it has been stated that the second train blows its horn, therefore qualifying it as the source. So we have the first train and we have the second train. So we have concluded to say the second train is the source and the first train is the observer in this case scenario, although they are moving towards each other. So this case scenario will help us determine the sign of the velocities once we are placing in our equation. So since we are being told that both of the tracks are moving, therefore they will both have some velocities which have been already stated. Now what form, or rather what formula are we going to use in order to determine the frequency of the first train rather? So therefore the frequency of the observer rather, which is train 1, is equal to the frequency of the source. And now we'll have the velocity plus or minus the velocity of the observer over the velocity plus or minus the velocity of the source. Now we are being told that both move towards each other. Always ensure that your observer is on the left hand side, or your assumed observer rather is on your left hand side, and the source, practically the one that emits or rather blows its horn, will be always at your right, so that you do not get confused on determining the signs which are to be used in your formula. Okay, so therefore the velocity of the observer, since it is approaching the second train and it is acting in the positive direction as seen, the velocity of the observer will be a positive. Okay, and since the velocity of the second train is acting in the negative direction, we'll have the velocity of the source being a negative. Therefore, we'll have the the frequency of the observer being equal to the frequency of the source being equal to the velocity v, and then of that of the observer, which is said to be positive v naught, over the velocity of the source being negative vs. Okay, so then replacing into our equation, we have the frequency, okay, but in as much as we have both of these velocities, they are not in their standard units. So let us convert this into their standard units. So we'll have 1.3 times 10 to the power of 2, okay, being equal to, so kilometer, just wrap that, kilometer per hour. Converting it to meters per second, we will have 130 multiplied by 1,000 meters over the 3,600. Therefore 130 times 1,000, we'll have it as 36.11 meter per second. Now converting the other velocity, which is 90 kilometers per hour, into meters per second, we'll have the 90 multiplied by the 1,000 meter over 3,600. We will obtain our velocity as 25 meters per second. Now substituting into our formula, we'll have the frequency of the observer being equal to the frequency of the source, which is this, so therefore it's going to be 500 hertz, multiplied by the velocity v, the velocity which is found in air, v, standard as 300, v being equal to 343 meters per second. Substituting it in our equation, we'll have 343, okay, plus the velocity of the observer being 36.11 over 343 minus the velocity of the source being 25, and therefore we'll have 500, 343 minus 25, we'll have 318 over 343 plus 36.11, we'll have our 379.11. Doing our calculations, we'll have the frequency of the observer being 596.08 hertz. Okay, so then if the second train has some form, is regarded as the source, okay, and produces some form of waves, okay, and these waves are acted upon the first train, in comparison to the frequency of the source, the frequency of the observer will increase. Okay, so this practically serves as the correct answer.